We have calculated the sum of the list of the number by defining a program using Python. So let's change the example and let's see what happens. Like in small letter, like let's say 0, 0, then let's say 0.23, then let's take 0.34, and let's see about 0.22. Let's add the numbers and let's see what will be the output. This is valid for any kind of numerical values like integer, float, or double string, any kind of this all done. So let's do one of the most important thing which we have to know, like uh, finding Fibonacci series. So let's do this. For that, we have to raise it and we have to start defining our function as Fibonacci, Fibonacci series of tensile. Then we have our conditions applied here. Then we will return the value of n, and then not next is incorrect. Then we will return the value of Fibonacci of n minus 1. We are using n minus 1 here because n is also included and 0 is also will be included. For that we have to minus it, and then we will have Fibonacci of n minus 2. Then we will enter it and we will have our for range for I in range of 8. We are using the numbers as well here, and then we will print the Fibonacci of I, which is included at 8. Then in like this, we can get a Fibonacci series as you can see 0, then 1, 1, then 2, then 3, 4, 5, 6, 8, and 13. If we change our number of range here as say from 8 to 15, we can see here we are getting here as 1, 0, 1, 1, 2, 3, 5, 8, 13, 21, then 34, then 55, then 89, then 144, then 233. So it is as a recursive piece here, and it will call itself until it will reach its destination, and output will be like this. So Fibonacci of branch 4 into two cells, not one. Like Fibonacci of 4 is Fibonacci of 3 and Fibonacci of 2, then 5 of 4, 3 of 2, and 5 of 3 is further divided of 3, and Fibonacci of 2 is divided with Fibonacci of 1 and 0. Unlike factorial, Fibonacci recursion branches each call responds to or more cells. That's why it gets slow for larger numbers like n. Here we have a recursion of two more patterns. So here we have two more patterns here we have to draw. Here we have greatest common divisor, that is GCD by Euclidean algorithm, and the greatest common divisor and reversing string like this. Let's understand what does it mean and what are the difference between recursion and iteration of the loop. So how does a recursion repeat? Like in recursion, the function calls itself with a smaller problem, but in iteration, the loop, like for or while, repeats a block of code. The difference here is like the function will call itself, like we have a function of a plus b, and we are giving the values of a plus b as one, one or two, one, two, then two, three, then four, five. We don't have to write it again and again. We have a function like a plus b, and that will be that value, whatever we choose, one after one, that will be included in that and will solve and will be executed. While in the difference is like in iteration is like it will uh, repeat the code one after one. We have a code and like we have a function of code which will be repeating every time until it find the answer what it be needed, or if the loop is in by like loop gets in by it out of range. Loops like have for loops have certain range. If that range will be completed, the loop will stop iterating or repeating itself. Or in while loop, the loop will repeat itself the code until it find the needed value or required answer. But in recursion, we have a function, we don't have a value. So in recursion, whenever we give values to it, it will repeat itself. So let's understand needs of this recursion. So in recursion, we need a base case to stop, but in iteration, a condition to stop or a fixed range. Like in while loop, we need a condition to stop that, and in for loop, we need a fixed range like 0 to 5, and it will repeat till 0 to 5 and will stop when it will find when its loop its range will be completed. Or in while loop, when it will find it when it will get the result or its condition is met, it will stop. But in recursion, there we need a base case to stop that. So if we talk about memory use of recursion, is like use the call stack or one frame per call. Like it uses it do frame by frame, and in iteration of loop, it happens in single frame and generally more memory efficient. So if we talk about efficiency of memory, here you can see iterations in loops is more efficient in memory. But here recursion is recursion do frame by frame call, so it is not that much efficient. If we talk about the suitable use for recursion is to sub-problem trees, learn factorial and divide and conquer. And we talk about iteration. Here we have simple repeated counting or accumulations. If we talk about which have risk, in what type of risk they have. So your recursions have recursion error. If base case is missing, yeah, you can see we need a base case to stop recursion. But if the recursion is missing, then there will be a recursion error. If we talk about iteration in loop, there will be an infinite loop if the stop condition is never met. Here also you can see if there will be no range, that will not never going to stop, or if there will be no conditions to be met, that will also not never going to stop. So there will can be also risk of uh, errors. So let's do GCD problems. Then we are going to do this. Let's erase this. Let's solve our mathematical expression of GCD. GCD will be of two words. Here there will be a def function. And there will be a condition if b will be equal to 0, then it will return a unless it will return GCD of b and a percentile b, and after that it will print the GCD output. We are taking an example of 67 and 645. Here we can see it is input the GCD value, which is 1 here. Let's take another example. 45 and 18. As you can see, the new GCD is 16. So this is only one topic. So we talk about reversing of a string by recursive function. So let's do it. We have a def function of reverse of string. We have a text. Then our condition of length of the text should be like greater than or equal to 1. That will be a minimum condition for that. Then this will return the text. After that, it will return reverse of a string. Then text will be of 1. Then it will add on the text of 0. And it will print the reverse of the number and string. So reverse string of, let's say, like hello world. So return. And you can see that HELLOWORLD is now become BLROWOLLEX. Like it has been reversed. When we talk about like let's talk about the number like 998877655. Here you can see it also has been written. Here is we have whatever we have written, it does not matter. In we have a double apostrophe comma here upside in the bracket of print. It will not see whether there is a number or a string or a name of a person. It will reverse the digits. That will be where the digits which will be at 10 will be at once and 1 will be 10 and so on like that. So here we have done two examples. Here we have factorial and factorial using recursion in two ways. The first one is in iterative ways and second one is in recursion. So let's do a factorial using both functions. Here we use first of all recursion version, def factorial of recursive of then make n is equal to 1 or less than 1, then it will return 1 or it will return n into factorial recursion of n minus 1. Here is an error which can be fixed by just clicking. Here you can see that program is not giving any output. Oh, what will be this? We can see, we can just see here that we are getting the result of the factorial of 5 using uh, recursion function. Like we can get factorial of 90 as 1487 like this huge number. And we will remove 0, then we will get recursion of 9 as 9 8 into 8. Let's max it down. Does it really work? You can see here that we are getting exact number what we have to meet. So this is a recursion version of finding factorial. Let's see iterative version then. So here we need to define our factorial in iterative. And this is the difference here. For that we need to remove, we don't have to remove this. So let's write it under this. In iterative version we will see the difference. So the result will be like equal to 1. Then for I in range of 2, n plus 1, then outside the bracket will be our result like this, and it will be multiplied then equal to of I, and they will return the result. So you can see that in the first case it is returning the answer as well, but in the second case it's just returning the result, but it's not showing the result. To show the result, you need to write here as string factorial, string factorial iterated of 6. Where you can see here as like 6 by the 30, then 4, 120, then 3 will be 3 will be 600, 720. Let's change this and let's see for other examples like this. We are getting 40320 for the iteration. for the factorial of 8 we are getting as 40,320, but for 9 we are getting 3,62,880. So by both method we can get our answers. Let's see further what we have. So we have some other applied examples here for functions and type conversions and recursions working together. So we have a temperature converter with default parameters, like we are able to convert it from Celsius to Fahrenheit, and we can do it for Fahrenheit for to Celsius as well. And we will do both for this. And we have function plus type conversion. This number input, like next year you will be your favorite, like this type of example we are going to cover. And then we have a def function, recursive power function. Here we have to find the power of any certain numbers and what power it should be. Like here we are in our example we have 2, and the power of 2 is 5. When we talk about recursive of digits often, here we have numbers like 4, 8, 2, 7, and we will going to find the sum of the digits of the number. Of here we have 4,827. So we are not going to sum like 48 or 27. We are going to sum like 4, 8, 4 plus 8 plus 2 plus 7. That will be 21. And like 4, 8 plus 2, 10, then 40, 14, that plus 7 will be 21. And then these will be our example. Then we have a division of our practice problem. These are the some examples which you have to try but by yourself, like recursive of factorial using write function of factorial n recursively, and then test it with the factorial 5 and factorial 0. This you have to do. Then you have to write a Fibonacci function. So here we have a question. I write a function that returns the nth Fibonacci number using recursion. So we have a temperature converter. Write a Celsius to Fahrenheit with a default of C having 0 means convert Celsius of 0 degree. That will be your default using type conversion. So in the fourth question will be your like recursive power. You have to write a power based expression which will have like base and its exponent, that will be power recursively without using double star or form. That means you don't have to multiply it like 2 in double star 5, not like that, or you don't like to have to calculate it like POW, then using base and exponent. You have to write it by recursively by using recursion function. And the fifth will be your question is reverse of a string, like we have discussed in our videos, like recursion of reversing a string. We had done like of reversing of digits of a string, like we have done of hello world, and then we have taken an example of numeric value, certain numeric value. That how these type of examples you have to do in question number 5. And the sixth number you have to do is GCD. You have to calculate a GCD of A and B. A and B could be any number. That also will be recursively using a Euclidean algorithm. Then you have a 7-digit counter. 7 question is your digit counter. You have to write a count of digits of n size recursively to return how many digits n has. That means you have to take a string or a number and you have to calculate the digit of that number. So yeah, the eighth question will be your palindrome check. So what is it? Palindrome check is write a palindrome text and recursively base case and length for 0 or 1. So the nine will be your arg will be also known as arguments. So you have to do args practice. You have to write a total mark or score that returns the sum and average of the marks. Like you have to take certain list of the marks, let's say 90, 55, 70, 45, 50, like that. You have to take those numbers and then you have to find the total of that and you have to find the average of that. And at the 10th, we have a recursion versus iteration. You have to rewrite the list of the sum you have to rewrite list of sum as a loop instead of recursion and compare these two. What are the difference? So this quick revision we also have we will do after the solving all the problems. Hello. 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 Now we are going to see some applied examples. So here we have the first example of temperature converter with a default parameter. So we talk about default parameter. Only we have a default value, like predefined value of something. Predefined value of something is called default value of that. We have functions, type conversion, and recursion working together. And then we have type plus type conversion to get next year we will be always these kind of example will be we are doing. And then we have recursive power function, an alternative to the power function. We have a recursive power function. So the first example is Celsius to Fahrenheit. Here we have a default value of Celsius T, that is 0. And then we have a formula of finding Fahrenheit using known value of Celsius. Like we have the Fahrenheit equal to Celsius into 9 by 5, and 9 by 5 means 1.8. That means 1.8 C plus 32 will be equal to Fahrenheit. Then we will determine the value of Fahrenheit F, and then we will see the printed value, the outcome of Fahrenheit in using print function. And then we will have print Celsius to Fahrenheit. Uh, second example, we will not going to assign the value to the Celsius. We will be using the default value of Celsius. Here you can see we have a default value of Celsius is 30 to 0. So that will be used in the second example. Here it will be printed using C equal to 0. And here in the first example, the cell for Fahrenheit will be we will get the Fahrenheit using Celsius value as 0. So like this we will going to do. So let's do it by ourselves. Uh, About temperature converter. So let's do here. Right. Firstly is def, then we will name our function like Celsius to Fahrenheit because we are going to do we are going to make a converter which will be Celsius to Fahrenheit at the default value of Celsius 0. So we will name the function according to that. So Celsius to Fahrenheit. Hence, we are going to take a default value of C as 0. Then we will write the formula for that. Formula will be like F equal to, that will be equal to Celsius into 9 by 5 plus 32. Then we will return F, and then we will print the. Now we have made our function as Celsius to Fahrenheit with default value of 0, and we created a formula to calculate Fahrenheit using Celsius, and then we are returning the Fahrenheit F. Now we are going to display the value by using print statement. We write it like Celsius to Fahrenheit of so 100 degrees Celsius. We will print this. We can see here that we are getting output as 212.0. So let's verify it in our formula. So here we have C as 100. So 100 into 9 by 5 is 180, and plus 32 will be 212. So our code is working properly and the formula is also good, also correct. So uh, we will show output for our default value by giving no user input. We will not going to give any input from our side, and we will see does it catch the default value itself, or there is any need of uh, improving our code. For that, we will write same thing like we had written it on the upside. So, then, here we have a spelling mistake. Celsius will be not there. Celsius to Fahrenheit. I'm not going to enter any value here because we are going to check whether our code is executing with default value or not. So we will run this code. As you can see here, we are getting 32. Let's verify our output with given code and formula. So we are having a default value here. Let's assume that our default value as 0, and in the formula we put C equal to 0. Then 0 into 9 by 5 will be 0, and will be plus 32 in it. Then 32 will be the output. And when we return the F Fahrenheit, and if we print the Fahrenheit, then we will get the output as 32, which we are getting in real. This means that our code is taking proper default keys for as well. So if we write in our default keys like foreign heights like 212, let's see what happened. Here you can see it's giving you the output as 413.6, and let's verify this as well. Like 212 divided by 5 will be, let's calculate in our calculator, like 213 will be divided by 5, and then that will be 42. And if we multiply 42.6 by 9, then we will get the output at 383. And we have another thing is that we have to plus 32 in it. And when we add it, we are getting 415.4, which is approx value. That is also correct. Let's verify it again. We have taken 212, which will be divided by 5, and then it will be multiplied by 9. Then if and we will plus 32, we will get 413.6. There was a tiny mistake there. So because of that, that was happening. And this is the formula for converting Celsius to Fahrenheit. But we have another formula which is not written here. But we have another formula which is opposite of it, which is like Celsius. This is Celsius to Fahrenheit. And we have another formula about Fahrenheit to Celsius. Let's give that formula as well. So let's talk about that formula first of all. So in uh, Fahrenheit to Celsius to Fahrenheit, if we talk about Celsius to Fahrenheit, we have a formula of like C into into 9 by 5. Then it will be add on by 32. This is the formula for Celsius to Fahrenheit. But if we talk about formula for Fahrenheit to Celsius, Fahrenheit, Fahrenheit to Celsius, we have formula we have formula as we are known about Fahrenheit, so we have F value and then the minus 32 from our Fahrenheit value, and then we will multiply it by 5 by 9. This would be the formula for calculating converter from Fahrenheit to Celsius. So let's do a program about this. So let's create our function of Fahrenheit to Celsius, and we will take our default value here as well. Like we have taken in Celsius default value, we will take here default value of F as 32, and then we will write our formula as same as we have written on upside. So C will be equal to this formula what we have written here will be written in here. So F minus 32 is written F minus 32 and that will be multiplied by 5 by 9. So then we will return this, return C, which is acting as Celsius. After returning the C, we will going to print it as well. Fahrenheit, not this type. Fahrenheit to Celsius. Let's take an example of 212. Like what we have got the output here, we are going to take that and we will check whether we are getting our inputs. Like here we have given 212 degrees Celsius and we are getting Fahrenheit of 413. And after giving the input as 100 degrees Celsius, we are getting our output as 212 12 Fahrenheit. So we will reverse these and we will get reverse answers of these things. We will make another print statement for the Fahrenheit with HG of 413 points. And we also check whether our default case is working or not. So by that, we are going to print another statement here. For default case, here we have erased our default case. We will right here, print Celsius to Fahrenheit for default case. Here you can see that we are getting an output of approx 212. In the second case, where we have our input as 413 and we are getting 100 as output when we have 212 degrees Fahrenheit, 12 to 212 Fahrenheit, we are getting output 100 degrees Celsius. In our default case, we are taking default case or as the 32 and if we verify this thing in our formula, 32 minus 32 will be 0 because we are now giving any user output, user input. We are using default value which is 32 with the 30 with the minus subtract 32 from 32 we will get 0 and if we multiply 0 by any number we will get 0 and what it is written on the last output. So our code is working properly in these converters. If we will again run this, it is executable. So let's talk about our second type of question, which is safe number input function plus type conversion combined. We talk about our second question, So let's do it here. Python compiler. So if we take this example, we have to define a function of getting a valid input, which is an age, because we are going to uh, predict our age, which will be what will be our age in the next year. We are going to make the program for that. So get a valid age, then age underscore text, then it will be equal to our input. What will be our input as insert your age, and after that we will return in age the text, and then age equal to get valid age, and then bracket, and then we will print to show our result, is it executed or not. So next year you will be of age, you will be age. So next year you will be of age, uh, here input. We will execute this code. We have not it here plus one. So here we need user input. So if we talk about 18, then next year we will be 19 years. If I want to write something more, years older, old, then 18, we will, next year we will be 19 years old. This is how we can write. Let's say, can we write it for infinite, like 999? We will be thousands years old. Here you can choose. It is valid for any number, like 99.98. Here you can see it is not valid for any type of number. It is only valid for integer types only. As you can see, there are valid age because we are not sending it a valid age. It is returning an error. So this is also being done. If we talk about recursive power function, which is an alternative to the power function. So if we use this as an alternate of this power function, so we have to define our uh, function name and then function base and expression exponential. Then we have our condition with this, like we cannot have our exponent as equal to 0. So we will not be doing, we are not going to enter expo as 0. So there will be our exponent, if there will be if our exponent will be 0, it will return 1. So after that, it will return our base into power of base having exponent minus 1. After that, we will print this to show to see the result. That's how you can get your result. Like here we have got 32. If we talk about we are positing, like in place of 5 we are putting 2, in place of 2 we are putting 5. Then you can see that the result has been changed. I will let you understand why this is happening. Because if we talk about 5, comma 2, and the thing which is happening here is 5 is getting multiplied twice, which is giving result as 25. But if we talk about 2 comma 5, like, let me write it first. And we'll talk about power 2 comma 5. The thing which is happening in the second column is here 2 is getting multiplied by 2, and it is also getting multiplied by 2, and it is also multiplied by 2. Then it will also multiply by 5, 2 5 times, and leaving as output 32. That means the first one will be our base and the second one will be its power. If we reverse the base and exponent, the result will be also different. So like this will be happening. Here I have to put hashtag so that it will not getting included while execution of the code. As you can see, this is as simple as it happening. If we take like printing something for power of let's say 99, power of 9 is this value, which is very huge number. So this is also then, so let's see what we can do different thing. Let's see what happens if we take our exponent as 0. Power same thing. The difference will be 23 and its exponent as 0. Let's see what happens. You can see here our condition which has been applied here, like where exponent will be 0, it will return 1. The output will be 1. It doesn't matter to BAR rating 23 or anything. Either if we write here like, this is an example you will understand. We either write here like power of 0 comma 0, the output will be 1, because it will not see whether your base is 0 or not. In general, if you have a power of uh, 0 to the power of 0, it is 0 because 0 is getting multiplied by 0 none of the time. So the output will be also 0. But in 23 having power of 0, it will return 1 because any value having power 1 is 0, is equal to the 1. So this is how it is happening. Let's say if we are printing for the powers having value less than 1, less than 0. Let's say we have a base of 4 and the power is -2. So here we can see that power should not be in negative sign. We have to define our power. So it can be 0, it can be any number above the 1, but it cannot be 0. So you can see here we are getting proper output when we put positive numbers along with 0 in the exponent. And we write here we take another example, different example of base having 0, but the power is having, let's say 8. Let's see what happens. Like same thing, 0 is getting multiplied 8 times, 0 into 0, 4 to 6 to 8, 8 times getting multiplied, leaving the result as 0 obviously. That's why it is returning 0 as the output. The example is also done. Now we have recursive digit sum. It will repeat itself and it will give the sum of the digits in the number given. Let's write that example. We will going to define our function as digit sum because going to solve it for we are going to do digit sum, so we are naming it accordingly to that as well for a proper understanding. So the function sum of n, and then we have our conditions. If n will be equal to 0, then we have to return 0. If the numbers are 0, numbers of digits are 0, we have to return 0 unless in other cases we are going to return 10 percentage point plus digit digit of sum of the digits of the number, and then in double slash. And we are rating this because we are doing recursion of this function because of that we are writing this statement. After returning the result, we are going to print it to show how what happened here. So digits, then sum of 4827. Let's see what will be the output here. We can see here by this code we are getting our output as 21 because 4 plus 8 is 12, and then we have 2 which is 14, then we have 7 as well which have value like 21. Then if we write 100, 1000, 10,000, let's say. What will be the sum of the digits? That obviously will be the 1 because 1 plus 0 in many, you can take it any a number of times of 0 getting to add on to the 1. It would be 0 and remaining thing will be 1 as the sum. So in 1,100, 1 lakh, 10 lakh, nothing matters. The sum of the digits will be 1. But if we talk about not 1, if we talk about 10 versus, let's say like we are printing digits like some of the digits like we are taking example of we have taken 10 and we are taking 9. And if we are thinking like the sum of 10 will be greater or sum of 9 will be smaller because 9 is smaller to the 10, that will not matter because we are adding to the digits. 1 plus 0 will be 0, but 9 plus 0 will be 0. So here you can see 9 will be printed for the sum of digits in the 9. If we talk about 99 and 100 as well, you can understand as well because a simple math and a simple logic as well. You can see here 99 and 100, they are different. 100 is bigger, 99 is smaller, but 99 we are adding its digits to its digits. We are sum of the digits of 99 we are getting 80, but the sum of digits of 100 we are getting one and one only. So I think that will be understandable for us. So if we do our quick revision,